말을 위로 하면 되나요? 아, 네. Good morning, everybody. My name is Hyoseop and I'm working at this small company, Encored Technologies. We just started the business just 1.5 years ago, but actually we already produced some product in the market. But anyway, I think I'm the case where who working at the smallest company as a mathematician. So maybe that's why I'm talking here. So I listened the previous talk and then I checked my previous experience too because I want to check whether I'm the meet that the Google guys that the strategy is a recommendation. So actually I started at I was a programmer at a startup company and then returned to the university to get a degree. And I did an internship at Bell Labs and go to the Wyoming as a postdoc. And I hired as a researcher in Bell Lab Korea and then now I am here. So actually there are many stories between them. Well, actually I just briefly explain something. So the programmer, my major was mathematics, but actually the reason why I worked as a programmer is that the military duty. So just to avoid the military duty in Korea, I just work as a programmer. So that's why I learned program at the time. There's no reason except for that. And then, after 3 years the experience as a programmer, I really want to study mathematics because I worked as a programmer. I just really hate at that time programmer. So they returned to the university to major mathematics again. And then went to the internship in US. There's another story. So I think the one talk will present tomorrow, and then I just met him. Coincidence, just met him, and then he recommended me. Do you want to do internship? So I said okay, yes, and then we went to the US for the internship. Well, actually, I didn't know what I will do that at the time. But at the time, I did some kinds of mathematical modeling, and then I realized that this kind of math exists. So before that time, I just do applied mathematics, and then this is all about the textbook. Well, actually, at the time, I did some kinds of the market modeling, and this is about how iPhone will affect in Korean market. So this kind of market modeling is really interesting to me. And then so that changed my direction for the research. And went to the Wyoming as a postdoc, and then we studied the supercomputing programming, and we hired the Bell Labs after that. And actually so the company where I'm working is that the startup company funded by the Silicon Valley VC. So initially, this guy, he's a very well-known guy in the energy industry. Well, so he got funded from the Silicon Valley at the time. So the $1.5 million was invested to his company. So he started the energy business with electric engineering guys. His major is electric engineering, and he hired electric engineering PhD, and did some work and realized that they cannot do that. So after that, he tried to find mathematicians. And then the mathematician he found was me. So actually very recently, we got close at the Series A funding. This is a 5 million investment by these companies, the Formation 8 and the Samsung and the other companies. So he's very famous for the ventures in Korea because this is the very highly valued company because we just spent 1.5 years and our valuation is more than $16 million. So he's very well known, but actually the older slide when we do IL is about mathematics. So all that the venture capitalists were surprised that all your slide is about mathematics. That was very nice because they cannot ask anything. So they could not ask anything because there are too many mathematics. So we prove our business by mathematics. One of them, some of them was about the non-intrusive load monitoring, and then the demand forecasting based on that, and the optimal load control, and the operational analysis, and the behavior analysis, and money. So we propose 5 very unique algorithms and the unique business area using that based on that the mathematics, and then the investors conclude that this is the worthwhile business. So we are creating many ideas, and then we are submitting, and then already got many patents about those ideas. An IRM algorithm, and then event simulation, such algorithms. We already submitted more than 10 the algorithms, and then we got the many algorithms already issued. So our company is very unique in that there are too many PhDs and then masters and mathematicians. We are too overeducated in some sense. So we have 5 PhDs among 20, and 7 masters, and especially we have 3 mathematicians, and the percentage is just 3, but actually this is dominating major in this company. So I will control that, the dominating the ratio. But anyway, so we have the two PhD in mathematics, and one master in mathematics, and then we are continuously hiring the mathematicians for developing algorithms. Even though we are energy company, we only have 5 energy guys. So the others are all about the algorithm and then the software development and sales. So our vision, not our vision, my CEO's, the company CEO's vision is the energy startup with $1 billion value. My vision is a little bit different from this. $1 billion company started by mathematicians. But I think I can prove this one by make the company as $1 billion company. Well, actually, this is possible in this era, because by using mathematics, we can create a service. Actually, before that time, previously, it was really hard to make any service or any tangible things using mathematics. It's a bit far from the practice, but now we have lots of tools and then lots of nice algorithms that can make real things using the mathematics. So I believe that we can make $1 billion company just by mathematicians. How? So actually, I put that the Honeywell, but I erased that one because I do not want to debate with the Honeywell. So anyway, so we are energy company, but our focus is a bit different from the conventional companies. Our focus is consumers. Traditionally, the energy companies always focus on the suppliers. So national grid and the very big buildings operation, but we are turn our attention to the consumers. So it's a bit debatable, but anyway, from the point of supplier's view, the problem is simple, and then the electric engineering focus. If the problem is go to the consumer market, problem is really complicated because there are too many individuals and then too many different behaviors that appear. So those things should be modeled using mathematicians. That this is not a traditional, conventional electric engineering problem. Now, this is really mathematical modeling problem. So that's why mathematicians can make the things better. So we introduced that service, the Energy Planner, and then there are software platform. This is software platform, and this is the hardware platform. When I introduced, and then when I explained this service, then everybody asked, isn't it a meter? Isn't it just a power meter? No, this is mathematics. So we do not just we measure that the power consumption, but this is not all. We are doing all about mathematics, just based on the data. So before we go, I just need to point out these facts. So the Korean government tried to spread that the AMI, the conventional meter in Korea, and then this costs about $220 per person. And actually the power meter consume power itself. So the power consumed by the meter is that the 1.5% of total nuclear generation in Korea. This is the serious case because the power meter itself consumes too much power. And then these things cannot give any value to ordinary customers. So we developed another device to measure the power very efficiently. So this is the conventional meter, not conventional one. This is the smallest one in Korea, but this excluded the communication module and consume the lots of energy, like at 2 watt, more than 2 watt. But actually our device is much smaller than the previous one. But actually this included the Wi-Fi modules too. This is the device. So we made this device, and this is the starting point. Oh, let me show our the product more, because at the startup, my boss always told me that always advertise our product if you have any chance. So, as a startup, I think the speakers as a very well-known companies, they do not need to explain their product, but I have to. So this is that the Korean traditional circuit panel. It looks like this. So inside the circuit panel, we can just plug in this product into that one. So very simply, so everybody can plug in this product to the ordinary circuit panel, but actually I cannot. This is the circuit line, so I cannot. But anyway, he can do it. So this is very simple product. But it is simple, but service is not simple. So we measure all the power consumption and send it to the servers, and then we analyze all the data, just analyze the data. Real-time monitoring and forecasting, and then giving detail, NIRM and comparison. The NIRM, this is our fundamental technology. So the NIRM, this is the non-intrusive load monitoring. So as you can see here, so we only measure the main power line. Well, actually, we can analyze that how much power is consumed by oven and coffee machine and refrigerator and light. So this is our fundamental technology. We analyze just the very detailed analysis just based on the total consumption, and this is that analysis is the nice input for another problem for the load testing and then the appliance monitoring and the other services. I will explain a little bit more, but anyway, this is based on that mathematics. So we are providing the apps and these kinds of the face and all the services based on the mathematical algorithm. So even though this is just simple, but all the math inside that is very complicated. Especially for home, this is the home product. And we also have for the building product, but this is too big to that moving inside my pockets. So anyway, this is the home product. For the home product, we are thinking that for the home product, the energy saving is not important. Energy monitoring and analyzing the energy and manage the energy, this is very important, the point. So we provide the forecasted bill and then the top 5 uses. So this is the usage by each appliance. So so for example, the refrigerator and the air conditioner and so on. So we analyze the total energy consumption, and then we recognize which consume how much energy. And then using this kind of thing, we can analyze that the tiered plan, and then we can forecast, and then we can recommend how the energy consumption will be. For buildings, we can analyze a little bit more. So we do that the lots of data analysis. So we will the forecast where the peak is, and so that the building owner can avoid at the peak load, and how to shift that load to that the off-peak time. So I will explain about the fundamental technology for the NIRM. We are calling this is the energy fingerprint. So each appliance has a specific fingerprint, specific feature when they turn on and when they operate. So we analyze that such specific pattern, and then we extract such patterns from the total consumption. I do not give the details for that the problem and then the models, because there are too many mathematicians. I do not make my market is too competitive. So this is that this is the 1 second measurement of the power. This is active power. So from this kind of the pattern, we extract that the refrigerator pattern, and then the washing machine pattern, such kinds of pattern we can extract. So this is one example that we are extracting this kind of the pattern for the rice cooker. So we applied all that the method, what I know, and so we got the information like the active and the reactive power, and then the clustering, the steady and then transient state, and then we analyze transient state and also the steady state, analyze the harmonics of power and the user behavior too. So we did an experiment. So with LG Electronics. So this is the software-based the disaggregation result, and this is the smart plug result. Do you know the smart plug? So you can plug in when you plug the appliance to the outlet. There is the intermediate plug. So you can plug into that, and then they plug that one to the outlet. Then that measures the power consumption, because that is just directly the connected. So we installed the 10 smart plug at our home, and then we measure which the result matches well. So yes, here is the kettle. As you can see here's the kettle, and then this is the defroster, and then this is a kimchi refrigerator, and then these are just a normal refrigerator. So we conclude that our technology works very well, but this is the prototype, and so we are developing further to make it release in the market. But anyway, this is the state of art technology. The funny thing is that here's the defroster and the refrigerator. Initially, we thought that we can extract refrigerator exactly, but actually the refrigerator has the three main parts: the compressor and defroster and the light. So initially we very disappointed that oh man, so the refrigerator is split into two different things. Well, actually this is very useful, because when you look at the refrigerator, then something is wrong, but you cannot open, and then you don't know which part is wrong. But because we can extract from the refrigerator the compressor part and the defroster part. If something is wrong from the power pattern, then you can recognize that this part is wrong. So this kind of the diagnosis can be available from this analysis. So this is the platform for the analyzing and gathering the data. This is all the mathematics, not math. So when we're sampling, and then they send the data encrypted, and then the combinatorial optimization problem for an item, and then the behavior modeling for the user behavior pattern detection, and the for the storage control, we also did this kinds of mathematics optimization for the storage control, and then the forecasting, and then the operational analysis. So those are services based on that the search analysis. This is the diagnosis service, because we can extract the pattern, and then we can compare the patterns, whether this pattern is the normal pattern or this is abnormal pattern. This is the abnormal pattern detection. So we already installed this one to factory, and then we detected the abnormal operation of the machineries. And these kinds of things are the user behavior analysis, and then from that we can make a better forecast based on the user behavior. And these are some kinds of HVAC control based on that the NRM the analysis, and this is the building HVAC control based on that. And we can compare each appliance's usage with a neighborhood, because we know that the users the appliance energy consumption the pattern. And this is just the word. So we want to be legendary. So we need a mathematician. So our vision is maybe too big. Well, actually all that the things can be supported by mathematician. This is my conclusion. Thank you.
Okay, so we'll continue to